What is going on, everybody? My name is David and welcome to my network guy on the Run channel. In today's video I will be discussing IPv4 addresses slash subnetting at the same time. So this video will be talking about IPv4 addresses and subnetting. As you can see, I've listed the IP addresses along with the classes that these IPv4 addresses are in. So for example, within the class A, you have 0 through 126. Class B, you have 127 through 191. And class C, 192 through 223. Class D, 224 through 239, which is your multicast addresses. And then you have your class E, 240 through 254, which is for experimental. So these are not used to my knowledge, or if they are, I don't know why they're using them for, but I guess I don't know. But class D are your multicast addresses. However, in my CCENT book, I was told that class E may be used. I'm not sure how real that is. It was in the book. It might have been an idea at the time when the book was printed. So, and I'll leave the link in the description boxes below on my study tools and what I'm using currently for the CCENT certification and the CCNA certification as well. So anyways, the way the classes work with the IPv4 addresses, let's just use this for an example under the private IP addresses. This first 10, because this is the very first octet. An octet is basically the numbers that are in between the dotted decimal notation. So this is within an octet, the 10. This 0 is within the octet. This 0 is within the octet, and so is this 0. And these dots, again, they're called DDN, dotted decimal notation. So for example, this 10, because of the very first IP address, it falls within the class A IPv4 addressing scheme, because 10 is between 0 through 126. 172 is within the class B, because 172 is between 127 and 191, which is the class B IPv4 address scheme. And then 192 is within the class C IPv4 addressing scheme, because 192 through 223 falls within the class C. And I'll just make this brief when it comes to the private IP addresses. These addresses are considered private, and the reason they are considered private because these are used within a private organization, meaning these are non-routable IP addresses. These addresses cannot be routed through the internet. They just can't. They're just used within the private network, so those machines can talk amongst themselves, communicate with one another within their network, within their organization, or whatever you want to call it. So that's all you need to know. But definitely remember these. If you are going for your CCENT and your CCNA certification, mainly CCENT, let's say for example, memorize these private IP addresses. This will be very beneficial for you. And just remember too that these IPv4 addresses are not routable on the internet. Now, with that being said, let's go ahead and get to the juicy part of the video, because I really want to make this video brief, short, and to the point. Okay, so when it comes to subnetting, excuse me, to find the number of subnets within a network, you do 2 to the n, where n is the number of bits borrowed to make the subnet mask. You may be asking yourself, what does he mean by that? If you're new, if you're experienced, then you know what I mean. But if you're new to the networking field, you want to get your feet wet and learn subnet, and then I'll discuss that later in a little bit, I should say. We'll move on to point 2, the number of hosts within the network. So 2 to the h minus 2, where h is the number of bits, meaning zeros, that are left in the subnet mask. That's how you find how many hosts you can have within that network. And you may be asking yourself, where does this minus 2 come from in the formula? Well, here we go. The 2 comes from the network ID. You subtract 1 from the network ID. That's where the 1 comes from, and now that leaves you with 1 left. And the next one is for the broadcast address. I'll talk about that in a little bit as well. And we have a third one too, called the magic number. The magic number is 256. And this can make this easier to let you know how many to get to the next network. So what I mean is, example will be, we'll use this 224 for example, right? Use the magic number 256 minus 224. It's 32. Just keep that 32, keep that magic number in mind. Now to find the networks of, to find how many subnets this the subnet mask can have, let's go to the calculator. Remember, N is the number of bits borrowed. So this /24, we're gonna roll with this /27. We'll roll with the /27. It's borrowing 3 bits. So basically you're doing 2 times 2, which is 4, times 2, which is, it's not trying to highlight, which is 8. 2 times 2, 4 times 2 is 8. So this subnet mask, if you use a /27, can have a total amount of 8 networks. To find the number of hosts, you would do 2 to the host, meaning the zeros minus 2. And we're gonna stick with this /27. So as you can see, it is 5 zeros. So let's go to the calculator and do the math. 2 times 2 times 2 times 2 times 2 equals 32. What does it remind you of? That magic number, 32. But from that magic number, you subtract 2, which gives you 30. So within the network, this can have a total amount of 30 IP available addresses that you can use. 30 IPv4 addresses that you can use. You cannot use the network ID, and you cannot use the broadcast ID. I mean, not broadcast ID, sorry about that. The broadcast address. I'll give you a prime example. We're gonna, before we even get over here, let me go ahead and do something right quick. And as you can hear when I'm not talking, you hear the little noise in the background. Well, that's the cooling, the air cooling pump from my gaming computer. So that's why you hear that noise in the background, because my microphone is right next to my PC, and that's the that is the what's the word I'm looking for? Basically like the water pump, in a sense you can say, the cooling system that's keeping my processor cool. It's keeping that Intel i7 cool. Know what I'm talking about? But anyways, back to what I was saying. We're gonna look at why, because I got off subject talking about the PC. But anyways, we're gonna get into this. Example, we'll use the /24. No, we're gonna just stick with this. 255.255, right? Actually, I can use this. Matter of fact, you know what? We'll just do this. This is what we will use, and we will use. We ain't gotta worry about the slash. I'll just break this down for you right quick. Anyways, when you're doing subnetting, and because we are using, you know what, let's just use the /24 for example. Because we are using the /24, the 192 is the first octet. It falls within this. Therefore, because the subnet mask is all ones, this will be considered your network ID. So you cannot change this network ID. The second octet, which is all ones, as you can see, is 255. You cannot change this 168. Why? Because the subnet mask is all ones, and that's considered your network ID. You cannot change that. The 0. As you can see, the third octet, 255. You come over here, it's all ones, that's 255. So you cannot change that 0. But if you notice, these are turned off, meaning these are your host bits. So if you're running with the /24, the network is 192.168.0, because remember, 192 falls under this 255, the second octet falls under the second 255, and the third octet falls under the third octet falls under the 255. Because these are not all ones, these are your host bits. The 0 means your host bits. So therefore, you can use 192.168. I'll just write down here. You can use 192.168.0.1. That is your very first available IP address. You cannot use .0.0. That's not going to work. So you have to use .1. And you can use all the way through 254. You cannot use 255 because that will be considered the broadcast address. So 192.168.0.255 is your broadcast. Remember, if you can't use 0 and you subtract 1 from the magic, matter of fact, we just go off this. To find the number of hosts, 2 to the H minus 2, right? If you add them up, it's going to come up to 256, right? Well, 256, you take 1 from the broadcast message, and then you take 1 from the network ID. That leaves you with 254. You basically take the 2, subtract it from 256, that magic number, and you left with 254. So you'll be able to use 192.168.0.1 through 192.168.0.254. And if you didn't get this example, don't worry about it. We're gonna use another exercise. Now you may ask yourself, how does these come up with 255, all these ones? It's very simple. This is how you do it. You know what? Start from the larger number to the least, to the lowest number, the highest number to the lowest number. So 128, 64, 32, 16, 8, 4, 4, 2, 1. And this is 1. Sorry about that. 1, 1, 1, 1, 1, 1, 1, 1. You do the math. If you add 128 up, if you add 64, 32, 16, 8, 4, 2, 1, that's going to equal 255. That's where all these come from, meaning that all the bits are on. And as you can see with this one, because this actually has these the bits, all the bits are on. So you notice that the /25 has a 128. That comes from this 1 bit, as you can see over here on the chart. This 1 bit is on. So this is off. You see how I'm doing this? Well, you do 128 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0. Your answer is 128. If you do it this way, you do 128 plus 64, and that gives you 192. So you do 128 plus 64, which is 192, and then the rest is all 0, so there's no purpose on adding those up, and then it just keep going down the list. So that's how you come up with the 255s with the all ones. You're just adding when the one's on, you're just adding them, and that's all you're doing. And I actually copy paste that. I actually keep that pause right there for a second so you guys can screenshot it and do whatever. And to get this, practice. Stay consistent and practice. You will master this. When I first started learning IPv4 subnetting, I didn't quite understand it, but through practice and being consistent, I end up learning how to subnet. But anyways, I'll go ahead and get rid of this, and we're gonna do this for an example. And before we move any further, this 195, can anybody tell me which class this 195 is in? Is it within the class A, class B, class C, class D, or is it class E in the IPv4 class IP addressing scheme? I'll give you a moment to think about that. Do 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 boom doom. The answer to that question will be Class C. And as you can see, 195 is in between 192 and 223, which means it's within the Class C IPv4 addressing scheme. Anyways, let's go ahead and get on to it. And as you can see, I use it as the prime example as the magic number, because you take this 224, right? And how I got that 224, you remember, it's binary. 128 plus 64 is 192, right? Plus 32. What's 32 plus 192? 224. And that's where that 32 comes from. And that 32 is an important number because each network it goes up 32. And what I mean by each network, you see how I have 195.23.5.0? Well, guess what? The next network will be 195.23.5.32/27. Guess what the next network is going to be? 195.23.5.64/27. Or you can use this, because you actually have to use that when you're typing in your subnet mask when you want to configure an IP address on your router's interface. Anyways, and it's the same. It goes like this: 195.23.5. What's that? 96, and etc. You see, the network goes every 32, because remember, this 224, you're subtracting that from the magic number, which is 256. So it's going by 32. But remember, you cannot use the network ID, meaning you cannot use this .0. Remember, subtract 1 for the network ID and 1 for the broadcast address. So this down here, for example, well, we use .0. .0 is the network ID. You cannot use 32 because 32 is the next network. It is the very next network. So if you cannot use 0, guess what else you cannot use? You cannot use .31. And let me actually put that down there for you. You cannot use the .31 because that is your broadcast address. So in actuality, the IPv4 address, the IP address that you can assign to your host, or you want to give to your router within that router interface within that network of .0, you would use the addresses that you have available to use will be 195.23.5.1, because this is your network. And matter of fact, let me actually just separate that right quick. 195, I'll make it easy for you guys, .23.5.1 equals let me do this for you to make it easier for you guys. Sorry about that. 30 equals let me delete this. And as you can see, in this .0 network, the first available IP address you can use is .1. The last available IP address you can use is .30, because remember, you have to subtract 2 from that 32, because 32 is the next subnet. So we'll move on down to this one. Because .32 is a new network now, it's still within the /27, but remember, this can hold 8 networks. So this is the first network right here. We're working on the second network as we speak. So 195.23.5. Remember, 32 is the network ID. You cannot use that. So that's 33. And actually, let me do this again. Again, sorry about that, guys. That's my computer cooling system that you hear and the fans are running. My microphone is literally right next to the gaming PC, so sorry about that for the noise. I apologize for that, but there's really nothing I can do about it right now. So that is your first available IP address. And remember how I said that's 64? Well, 64 is the next subnet. You cannot use 63 because 63.63 is the broadcast address within this 32. So the last available IP address you can use will be 62. You know what? I can make it a little neater. Let me actually do this. Should I just do this? Nah, we'll do it. We'll do it this way. This is actually better for you. This is actually better. And now we move on. You get what I'm doing, right? Imagine you put a /27. Matter of fact, I'll do it different right here. And trust me, 255.255.255.224 is the exact same thing as saying the /27. As you can see right here, /27, 255, 255.224. So 195.23.5.97. And matter of fact, if you do the math, what is 96 plus 32? That is 128. Remember though, you have to subtract 2. You have to subtract 1 from the broadcast. Then you have to subtract 1 for the network ID. So since 96 is your network, 128 is the next subnet. That leaves you with 127 as your broadcast address. Remember, you cannot use 195.23.5.96 as an IP address because that is your network ID. And at the same time, you cannot use 195.23.5.127 because that is your broadcast address. So the available IP addresses that you can use are, you can use 195.23.5.97, which equals your first available IP address. 195.23.5.126 equals the last available IP address. And 195.23.5.127 equals the broadcast address. So you can give the host 197, 98, 99, 100, all the way up into 126, but that's where you stop. It stops right there. So in actuality, again, this can hold 30 available IP addresses that you can use, and by the magic number is increments every 32, and the number of networks you can have is you do 2 times 2 times 2, which is 8, and the number of hosts you can have is, again, and matter of fact, let me put a calculator up so you can see again. Matter of fact, we'll do that right now because we didn't do it on the last one. So it was 5 zeros. So again, 1, 2, 3, 4, 5 equal this. So it equals 32. You take that 32 because you're subtracting 1 for the broadcast and 1 for the network. So that you know that the /27, see the notation, that lets you know that the /27 or 255.255.255.224 can have 30 available IP addresses. And again, it's very simple, and we can actually do one more example. We can use one more example. So you know what? I'll get rid of this. Why not? Y'all get the point. Y'all see how it works. And then you just keep going, because 128 is the next. So then what's 128 plus What's 128 plus 32? That's 160. Well, you can't use 160 because that's the next subnet. You cannot use 128 because that's the network ID. So you have to go down 159. But you cannot use that 159 because that's the broadcast. So the addresses you can use will be 129 through 158 because 159 will equal the broadcast address. I'll just show you one more time. 195.23.5.128, right? You do 128 plus 32, that give you 160. Let me see. Let me actually put a /27 right there. 185.23.5.129. This is the very first available IP address that you can use. Right? The last available IP address you will be able to use will be 129.23.5.158. The last available IP address that you can give to your host. 195.23.5.159 equals the broadcast address, because 160 is the next network. And as you can see, we've already done 4 networks. This is a network right here. 195.23.5.0 is a network, and the IP addresses of 5.1 and 5.1 and .30 falls within this .0 network. The next network is 32. 33. Let me actually take that back. Let me actually reword this. In the .0 network, .1 through .30 are the available IP addresses you can use. .31 is the broadcast address. It's still within the .0 network. You just can't use it because it's used for your broadcast address. The next network is .32. You can use .33 through .62. Those are the available IP addresses that you can assign to your router interface or to your PCs, laptops, whatever. .63 you cannot use, even though it's under the .32 network, but you cannot use it because it's your broadcast. And I actually forgot one. Sorry about that, guys. I actually forgot one. I got overboard. Sorry about that. We'll do this one. I'm glad I went back and looked at it. So we'll use this. And this is simple. I don't mind doing this over. But that's my fault for not putting it in there anyway. So I apologize for that. 64 is the next network. 195.23.5.65 is the first address you can use. But y'all see how it's still gonna work in harmony with one another regardless. So you'll see for yourself. 5.94. Yes, 94. I had to do a little bit of math in my head just now. Last available IP address. And the broadcast will be, you guess it, it's going to be 95 equals and as you can see, there we go. Matter of fact, let me actually put that right there. Just keep them separated. That's how it works. So in this network of 64, the first available IP address is 65 that you can use. The last available is 94. 95 is the broadcast address within this 60.64 network. So now .96 is the new network. The first available IP address is 97. The last available IP address is 126. And the broadcast is 127. You cannot use that again. Next network, 128. 129 is the first available IP address. The last available IP address is 158. The broadcast message that you use within this 128 network is 159. That is your broadcast address. The next network is 160. And then you just keep working up until you get to 255. And that's basically it. I focus on Class C. As a matter of fact, we can just do one more example too. Why not? You will use these on serial links, and I will discuss serial links and whatnot when we do our RIP lab. Excuse me, sorry about that. That's allergies. We're going to use a /30. We are going to use this /30. So from here, what we'll do is magic number. We're going to get rid of this 32. And we're going to get rid of this 224. And we're going to give it a 252. 256 subtracted from 252 equals 4, right? Which means, just like how the 27, it goes up it increments every 32 to the next network. Well, 255 is going to increment every 4. So we'll just do something very simple. /30 or 255.255.255.252, right? And to find out how many networks this can have, we have 1, 2, 3, 4, 5, 6. So you do 2 to the 6. Let's go to the calculator. Let me clear this. 1, 2, 3, 4, 5, 6. Because it's a smaller number, this can actually have more networks. So this can have 64 networks, meaning let's just say, for example, and actually let me do this. 0. The next one, remember, increment by 4 because of that magic number. We subtracted 252 from 256, which gave us 4. So it'd be .0 is the network, .4 is the next network, .8 is the next network, .12 is the next network, .16 is the next network, .20, .24, .28, etc. They just keep incrementing by 4. Now, if you want to know how many addresses this can have, well, we're running the /30. So it's basically 2 times 2 is 4, right? But we're not finished. Remember, to find the number of hosts is 2 to the h minus 2. So 2 times 2 is 4. Subtract 2 is 2. Therefore, this can only have 2 available IP addresses. That is it. And I'll show you what I mean. 1.1.1. And it's the same as this because remember the /30, before I move on, has all 255s. It's not borrowed. The first 3 octets are not borrowing any bits. Therefore, it's all 255s. So these first 3 octets are not going to change because they're all 1s. They're all 255s in the subnet mask. But this is the interesting octet right here, because it borrowed 30. The /30 borrowed bits. But anyways, excuse me, sorry about that. So the first available IP address you will be able to use is 1 equals first available IP address. 1.1.1.2 equals last available IP address. 1.1.1.3 equals the broadcast. It's the broadcast address. The next network is, like I said earlier, .4. So equals, and I should have did this earlier, sorry about that. Next network. So, and actually let me do this too. /30. And you can use this. You cannot remember, because .4 is the next network, you cannot use this .4 because that's the network ID. You cannot use that. But what you can use is 1.1.1.5, which equals the first available address. Last available address will be 1.1.1.6. and the broadcast is. That is your broadcast address. And we'll do one more dealing with this one. 1.1.1.8/30 equals the next network. Remember, this network, the /30, can hold 64 networks, and the reason it can hold 64 because of the number of addresses that it have pertaining to each network is smaller than the larger numbers, like your /26 or 27 or whatnot. So, anyways, guess it. .9 is the first available IP address that you can use. That 10 equals the last available address, and you guessed it, 191.1.11 equals the broadcast address, but then this .8 network, and then of course the next network is 12, and then the next network is 16, and then 20, and then 24, and then 28, and then 32, and then 36, and then 40, and then 44, and then 48, and it just keep incrementing by 4s. That is it. That's all it takes. And you would normally use these on your serial interfaces just because you want to save IPv4 addresses. And that is it. And the reason why I focus so much on the Class C addresses is because that's what the CCENT and the CCNA focused on. So I'll keep this formula right here, and I'll keep it here for the next few seconds so you guys can actually take a screenshot of it and write down the formula. Let me actually go down there. I'll do that for a few seconds, and then I'll scroll down some more so you can screenshot the subnet mask and to see the notations, because this is very important to know, because this is important for assigning IPv4 addresses, and it's important to learn variable length subnet masking and whatnot as well too. So it's very important for you to know IPv4 subnetting, and it's not even just for the exam, guys. It's just for what you would need to use in the real world. Anything network related, you have to know IPv4 subnetting. Mind you though, for exam purposes, you do want to know these formulas, right? But in all actuality, in the real world, you have subnet mask calculators that can do the math within a snap of a finger faster for you, where you don't have to worry about doing all the math yourself. But for exam purposes, you have to know it from scratch. You have to know the formulas. But for the real world, to be honest with you, you have subnet calculators and whatnot, so you don't have to worry about it too much for the real world when it comes to stuff like that. But for the exam, you do need to know it, and I reiterate that because you really need to know IPv4 subnetting and how subnet masks work. You have to know these things. It's very important for you to take this information down and just practice. I came from a job where I was working at UPS, and I was studying subnetting at the same time, and I've got it down. So if a person like me can do it, there's no reason why you can't do it. If you put your mind to it, you can definitely get the job done. Have confidence in yourself, believe in yourself, and just practice every day. Practice. Even if you're practicing 30 minutes a day, you don't even have to do 30 minutes at a time. Just do 15 minutes this 1 hour, take a break for 3 or 4 hours or whatnot, and then do it for another 15 minutes. That's your 30 minutes. That's all you have to do. You don't have to do 30 minutes per day. Just do not 30 minutes per day, but 30 minutes in one setting. Break it down. Make it easier for your brain to process the information. Nobody knows how your brain work other than yourself. But anyways, guys, I really do hope this video was informative for you, and thank you for watching my video. If you like what you've seen, please leave me a thumbs up. Please subscribe to the channel. I will really appreciate it. I have a lot more content coming soon. The next video that I will do is with Packet Tracer, show you guys on how to use the simple command line prompts. And I can't wait until we get into that, because I love getting into the command line prompt and just the command line interface, I say command line prompt. I mean the command line interface, because the CLI, that's what it stands for, command line interface. But anyways, that will be the next video to show you guys on how to use the command line interface. You know, I'm not going to break down every topic when it comes to the IPv4 because it's so much. But if you go back on my previous videos, really my first one, you can actually see that I have the ICND1 and ICND2 exam blueprints. You can always just go to google.com, type in ICND1 exam topics, ICND2 exam topics. Print those blueprints out and then refer to the blueprints. And again, in the description box below, I will leave you guys with the tools that I use to study for my CCENT and my CCNA. And again, thanks guys for watching the channel. Again, please leave a thumbs up and subscribe to the channel if you like what you see, what you watched so far. And if you want to continue to see more content from me, just subscribe to the channel. I'll be posting more videos. With that being said, I am out, and I will see you guys on the next video. Peace.